Okay, first off, we want to look at some how to draw an ellipse from an equation. So all the information we need. Firstly, sorry about this page because it's a bit messy, but we'll push on. They get better, trust me. So the first one here, if we have x squared over 16 plus y squared on 9 is equal to 1. So we know by definition that must describe an ellipse. It could also be written this way, like multiply through by 144 and gives you 9x squared plus 16y is equal to 144. It could be written like that. So be wary that could be a form for the ellipse as well. First things we need to do, we identify a and b. Pretty easy. A is squared, that's a squared, so a is 4, b squared, b is 3. So that gives us our values where our ellipse will go through the axis. That's a really ugly ellipse. Again, I apologise. The foci. What's our formula for our foci? Plus or minus a times e, and then is equal then 0. And so, firstly, to do that, I need to work out e. So what's e? E squared is equal to 1 minus b squared on a squared. Again, I've got b and a. I can throw those values in. I get the square root of 7 on 4. So there's my value of my eccentricity. Okay, we said for an ellipse, it's less than 1. So we substitute those values in. Gives us foci of plus or minus root 7. So we've got our plus or minus root 7 there. So 2 point whatever value. Approximate it. Throw it in on your graph. Directrices is a on e, plus or minus. And I've written y. It should be x. Let's get that straight because it's an x value. So let's change that there, because y would describe a horizontal line. X is equal to, because I know when I've got my semi-major axis, my major axis, my directrices will always be perpendicular to the major axis. So keep that in mind. So that's where you know where your directrices go. But a on e, so we get 16 on root 7, and 16 on root 7 sits out there. That makes sense. So we can draw it up. We know that we go through 3 minus 3 on the y-axis, minus 4 and 4 on the x-axis, foci at plus or minus root 7, directrices at plus or minus root 16 on root 7. We can draw it up. We know the basic shape of the ellipse as well, like we did with the circle and the parabola. Let's have a look at this one now. X squared on 36, y squared on 25. Again, get your a and b, find your eccentricity. And from that, then we can work out our foci, plus or minus a times e, with n 0, because they're going to be on this major axis. Plus or minus, that gives us plus or minus 11, 0. So that's those values there, plus or minus root 11. Directrices are x plus or minus a on e, which comes down to plus or minus 36 on 11, which is over there. So there we go. That's how we start to draw it. We know where it goes to the axes. We know its foci. We know its directrices from our formulas. So it's a case of remembering those formulas. So this time x squared on 25 plus y squared on 10. Again, find our eccentricity, determine our foci, determine our directrices, and then as long as we've got a and b as well, we can plot those points and start to get our shape of our ellipse, where our directrices and foci sit. If we look at this one, this is a case that's a little bit different, because this case your b is greater than a this time. So if that's going to be the case, so the y squared, the number under y squared is greater, that's going to change our major and minor axes. So in this case, the major axis will sit on the x-axis, because that's going to give you the larger value. So b squared, b is 4 and a is 3, which means it's not going to be, it's going to be the small of the two axes. So it's going to be the major axis and the minor axis this time. And that's what happens when the number under y is greater than the number under x under the x. So b is greater than a. So that's going to change our directrices and our foci. Our foci sit on the major axis, and our directrices are perpendicular to the major axis. So we have to change that around. So what does it mean for our foci? Well, not too much a difference, except foci, we said, would be the x coordinate of 0, and it'll have a y coordinate now. And it's just plus or minus b times e. That's the only difference. We find our b value, times it by the eccentricity, and we're able to get our foci there, plus or minus root 7. So that's what they are. And then we get directrices, so plus or minus b on the e, so it gives us 16 on root 7, so you can start to see where they are as well. So notice directrices this time are y equal to plus or minus, because they're going to be horizontal lines. So there's our difference there. Now, given bits and pieces of data, can we draw an equation of ellipse? Well, this time, just given the foci and the b value. Well, okay, can we do that? We got enough information there to do it. So, what are we seeing? We're getting a situation where foci is plus or minus 4, which means we've got to use a times e is equal to 4. If that's the case, e would be 4 on a. So we're able to get a relationship. We know as well b squared equal to a squared minus 1 minus, outside of 1 minus e squared. So b is 3, so we get 9 squared. And we've got a squared, 1 minus e squared, so, and e is 4 on a, so it gives us 16 on a squared. We're able to expand that bracket out. The a squared's cancelled, gives us a squared there, minus 16, which works out to be nice because a squared equals 25, or a would be 25, allows us to get x squared on 25 plus y squared on 9 is equal to 1. So we've got our a value, we've got our b value, we know where our foci are, and we can work out a directrices. That's plus or minus 25 on 4. So that works out nicely for us. So again, we are able to draw up, once we've got a, b, the eccentricity, which allows us to get our foci and directrices. This time we're told foci at plus or minus root 5. So the first thing I should be knowing is that, well, my major axis is going to be on the y-axis because the foci sit on the major axis and it's 0 times a y, and 0 with a y value. So it's on the y-axis. A is 3. So again, b times e would be root 5. So we're able to change around. What we should note as well, if it is the situation we want to find the eccentricity with a major axis on the other side here, we should note that a's and b's swap around. So a squared, b squared, 1 minus e squared. So the a's and b's would swap around like they do with the major and minor axis before. So just be wary that's the case. I don't know if we mentioned that before, but this is where we start to apply this one. So the a squared there instead of what we had the b squared. So the eccentricity would be written as 1 minus a squared on b squared. Remember, this is got to give us a fraction because it's 1 minus that. So if b squared's greater, if we've got a major axis and we leave the b squared on top, that'll give us a negative value, which is not going to work for us. So we expand it out, we get the b squared minus 5, and so we're able to work out b squared is equal to 14, so which means b would be the square root of 14, so that's where it's going through about 3.5 it looks like. So take the square root of 14, and then we got x values of plus or minus 3, so you can see that there. And so we can find our foci. We've got our foci. You can find your directrices and put them in as well. So that's where we're saying, once we've got some data, we can manipulate our algebra. And this is what you're going to do a lot in this course. Manipulate algebra to satisfy what you need. This time the eccentricity is 2/3. And the major axis is 12 units. So if that's the case, we have the eccentricity 2 on 3, which means that 2a would equal 12 as well. So, and a would be equal to 6. Now that's assuming, I've done an assumption here that the major axis is on the x-axis. It really doesn't say here. So technically we could swap our answers around at the end and that would still be true, because we could have our ellipse the other way and we'd still have an eccentricity of 2/3 and a major axis of 12 units. So we'll mention that again in a moment. But if that's the case and we get a equal to 6, then we've got our eccentricity, we can find the value of b. So b squared is equal to a squared by minus 2/3 all squared. B squared comes down to 20. We're able to draw up our ellipse because we've got our points where it goes through the major and minor axis, and we can find our foci, we can find our directrices, not a problem. And as I said, it didn't say which one was the major axis, so I would quite happily take x squared on 20 plus y squared on 36 being an answer. That would work as well. So that would be great. Be not a problem to take. So there we go. There's how we start to draw up an ellipse using the data we've got, finding the values of the where it cuts the major and minor axes, the eccentricity, which allows us to find the foci, find the directrices, and we're able to get all that information in our to draw up our ellipse every time.